Welcome back to Advent of Code 2025 day 9 part 2. We're in the middle of this problem which I paused last time, so oh god. All right, let's get back to it. So last time I feel like I'm close to having the right answer, but it's wrong. Let's start by first changing, instead of using Cartesian coordinates, let's use the same system they use, just so that we can actually print this diagram and have it look the same. Let's do that. Okay, so we want to switch these to i's and j's, right? And then this will be I, j, j, I, j, I, j. And then, oh god, everything has to change now. So we're saying if it's vertical, if the j's are the same. Maybe we shouldn't do this. No. We'll just, it means we have to change a lot of things and that might introduce new errors. Let's carry on use as x and y's. Okay, so the problem we have is that I'm not getting the right number here. So I want a method to check whether a line is... Okay, so let's have a look at all the methods we have so far. Is vertical, that's fine. Get unit vector. Let's make sure we've got some brackets around these things, just in case. Okay, that just looks fine to me. Oops, rotate vector clockwise. Rotate vector anti-clockwise. So yeah, okay. Is point on line. So the y value lies, yeah, in that range, and similarly the x value lies in that range. Looks fine to me. Get point intersection of lines. This is the one where we're just relying on this code working. So far it hasn't really shown any issues. Get intersection of lines. Alright. Well, anyway, so We've got a bunch of corners. Got a bunch of edges. We're storing them, and they're like directed edges, so and then this little piece of code here computes the computes the direction, which it computes the normal vector. No, what's the, how do you describe this? It tells us whether the outside is on the left or right. So let's check if this is correct. So this vector goes from 2, 5 to 2, 3. So it's actually going downwards. So the rest of the shape is to our left. So the outside is to the right. So outside left is false. Okay, so that seems right. Boundary is the boundary of the shape. So for every edge, we just add all individual points. Yeah. And the boundary, that's the boundary. Okay. I think I'm fine with that. Best area equals 0. All right. Also, one thing we should do here is... Oh, this is part 1. We don't care about that. So now this is the key method here. Is rectangle inside the shape? So we're saying a rectangle defined by this corner and this corner. They're two different corners in no particular orientation. We're asking, is this fully contained in the shape or on the boundary, or combination of both? It has to be a combination of both, because we know it touches the corners. So to do that, we check each edge of the rectangle. We should really have a new method saying is line inside, because is rectangle inside is just the same as saying all 4 edges are inside. If all 4 edges are inside, then the rectangle is necessarily inside. We should probably change that. All right, and then that's something to fix. And then best area. So we have the P1 in corners, the P2 in corners, if P2 is on. Okay, so we check if the rectangle's inside, and if it is, then compute the area. All right, let's compute this outside. This will be a time save. If area is less than or equal to best area, then continue. Skip it, because there's no point doing all this calculation if we know it's not even a better rectangle. So if it is, then we've found something. Okay, that will mean we don't compute as much. Okay. Right, now I want to say define is line inside. And the line is defined by 2 points, P1, P2. And we want to check if the line is inside. So it's basically this code here. Let's copy it in. So for each edge in all possible edges, intersection equals get intersection of lines with P1, P2 edge. If it doesn't intersect any... If it doesn't intersect that particular edge, we skip it, that's fine. Alright. So if they intersect at a point, we don't care about if they coincide. We care about the ones where it intersects at a point. That means they're perpendicular to each other. And this is a potential case where we may be going from inside to outside. Or vice versa. Where part of this line goes outside. So vec equals... So we translate the edge. The edge has a direction. We translate the edge to a unit vector. And then if outside is on the left, we rotate anti-clockwise to get the normal vector pointing outside. So this is an outside point, we believe. Otherwise, we go clockwise to get the outside point. Now, if let's just call this line. So if this point is on the line, right, because it, and it's not on the boundary of the shape, then that means we've found an outside point on this line. So return false. Otherwise, the line lies fully inside. Oh, no, that's okay. Otherwise, no, this is only true if the line, we know that it's already touching the boundary, but we do, so I guess that's fine. Inside. Okay, so then this all goes. So we want to return all these rectangular edges in out of all those possibilities. So we've got P1, and then we've got P1x with P2y. And then we've got P1, P2x with P1y. And then got P2 with P1x, P2y. And P2 with P2x, P1y. Okay. Still 12. Okay. Okay, so the example we know is failing is 9, 5, and 2, 3. Like that. Let's test this separately then. So I want to check if 9, 5, and 2, 3 lies in the shape. The answer should be yes. So let's print is rectangle inside, right? P1, P2, pause, 9, 5, pause, 2, 3, P1, P2. The answer should be true. It's false, okay. So the corners, P3, P4 are going to be pause 9, 3, pause 2, 5. So let's check if the lines are inside then. It is line inside P1, P2. Not P1, P2. P1, P3. True. P1, P3 is in. P1, P4. True. P2, P2, P3, false. P2, P4. True, true, false, true. So we got one false, so that's the wrong one. They should all be true. Okay, that's good that we've narrowed it down. So for some reason, we're saying 2393 lies outside of the shape. Okay, can we just not do this right now? Alright, so now... don't worry about these. So that's false, okay. Let's figure out what's going on with this. Print outside point. So it's saying there's an outside point. 83. Why is that? Print edge outside point. That's the edge, 9795, and that's the outside point. Okay. I need to draw this. So 9795, so that's a vertical line going down. P2, P3 is 2, 3. Is a horizontal line. This is a vertical line, so they intersect. Alright, fine. Let me just draw this out. Alright. First of all, let's just sketch this shape. So it's 7, 1. Alright, so I'm going to have to draw like a graph. Okay, so... Or can we... Do I have any software that can do this? Oh, whatever, I'll just draw it. Okay, 7, 1 to 11, 1. Okay, so that goes to the right. 11.1 to 11.7. That goes up. 11.7 to 9.7. That goes left. (9.7) to 9.5. That goes down. 9.5 to 2.5. That's left. 2.5 to 2.3. So that goes down. 2.3 to 7.3. So it goes to the right. And then we join back down. Alright, so let's make sure that we've calculated all these intermediate things correctly. So we've got print leftmost outside left. Let's check if that's correct. So we're saying 2523 is the leftmost. 2523, correct. We're saying outside left is false. Correct. So outside is to the right. Yeah, outside is to the right. Okay. What else? Check we got the boundary correct. No, we don't need to check the boundary. Okay, so is line inside P2, P3? So we are checking the line 2, 3. Okay, so that's what my diagram looks like. 2, 3. Two, 3. And 9, 3. Two, 3, 9, 3. Okay. So part of that lies on the boundary. Interesting. Yeah, okay. As now this says that the line we are interested in intersects with the edge that goes from 9.7 to 9.5. No, it doesn't. What? It should be 7.3 to 7.1. Okay. So basically, our intersection code is wrong. Should we just write a new one from scratch? I don't like this. Okay, let's not use this one. This is overly complicated as well. Get crossing point line 1. line 2. Only return a crossing point if they are perpendicular and the point lies on both. Otherwise, return none. Alright. So, if is vertical, line 1, is the same. The is verticalness is the same as the is verticalness of line 2. Return none. Alright. So they are different. So, what's the formula for getting a crossing point? 2 lines. You take the one that's horizontal. Okay, so if line is vertical line 1, so this one's vertical, so P equals, so the crossing point will be the x value of line 1. So line 1, take some arbitrary point of that and take the x value. And the y value will be the height of line 2. Line 2, some arbitrary point there, and take the y value. Else, it's going to be the other way around. So it'll be the x value will be that, and the y value will be that. If is point on line P on line 1 and line 2, return P. Okay, that's all, right? I don't need to do all this other stuff. This was just for the general case where they could have any gradient and I don't know. So get crossing point. If I replace this with that, so then we don't need that. So it intersects. Alright, try that again now. Get crossing point. Tuple object has no attribute y. What? Point and line. Oh, that's not a pause. There we go. True. Okay, now we got true. Let's enable all of these. Oh, damn it. So these are all true now. Alright, let's go back to the original problem. 24, that's the correct answer. So was that the problem? The problem I was just using something I got from Stack Overflow, which was to compute the intersection of points, and it was just trash. And because we know they're always vertical and horizontal, you can write a simpler crossing point method. Well, we'll find out. First, get rid of a lot of these print statements. What are we printing? Because there's going to be too much printing. Okay, 50, 24. So that's correct for the example. So that was part 1. And part 2 is going to take a while. But at least we're now skipping areas which are... Okay. Let's try this. No, it's too low. Fuck. Now we're in this situation. So apparently there's a better rectangle out there. So... Damn, I don't know where to get started with this. It's gonna be some weird situation, isn't there? Oh, what if... Oh no. Oh no, 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 no. So what if... There's a situation where... Is it always horizontal followed by vertical followed by horizontal followed by vertical? What if it was a line that goes back on itself? Is that allowed? I don't think so. I think it's non-self-intersecting. If it is self-intersecting, then that breaks some things. Yeah, it looks like it follows a pattern. Okay. Hello, Amaro. Trying to fix this polygon thing. Well, I've got it working for the test example now. Doesn't work for the big example. It's too low. So there's some bigger rectangle out there. Today's one, yeah, I did that one. That was pretty quick. I used matrix multiplication to get the numbers of paths. Alright, where do I begin now? So that's the best area we found, but apparently there's a bigger rectangle. So we don't need to iterate. We're iterating both ways. Oh, it doesn't matter. I think, well, clearly there's something wrong with this, isn't there? So we've got the right edges, have we? So a rectangle lies inside the polygon if all four sides lie inside the polygon. That's what I'm saying. And that only holds true because, well, yeah. Oh my, hang on, that's not true. Oh, that's not true. I need Microsoft Paint to show a counterexample here. Oh. Yeah, this is not true. So you could have, so you've got your polygon, right, whatever. And then you could have, like, this. And then you could have this, where the edges just meet each other like this. They're right next to each other. Then, like that. So, if you had a rectangle, it goes like this. Then, technically, the edges of that rectangle would all lie on the polygon. That's a zero gap. However, this is technically outside. Wait, what happens in that situation? I don't understand. Does that mean we color this green or red, or what? I need to look at the exact wording now. How do we actually color? All of the tiles inside this loop of red and green tiles are also green. They haven't fully defined inside this loop. like I've just drawn something which is a loop. It's non-self, it doesn't technically self-intersect. It's actually non-self-intersecting. That space, is that inside the loop or outside the loop? It's outside the loop, I would think, but then... But they haven't really defined it. Alright, let's say... it's outside the loop. Then... it's probably an example I'm failing on. Because I'm assuming that if the rectangle crosses like this, then the rectangle's fully inside. Oh man. What do I do about this? Okay. Maybe this edge approach doesn't even work then, because you can't rely on edges. How about instead... how about instead we just... we've already made a boundary, which contains all the points of the boundary. So how about we just look to the outside point from every single point on the boundary. So it's like the outer layer, which is one space out. And that's all the outside points. And we say any rectangle, if it doesn't contain any of those points, then it's safe. Would that work? And then we don't have to worry about all those intersections of lines and stuff, which doesn't seem to work because of this counterexample. How big is this boundary? That's the length of the boundary. $500,000. We've got this many points. Okay, I'm not sure that would work then. What else? Well, how would I detect this then? Like, okay, so this rectangle would be this corner, let's say, and that corner there. That contains an outside space, but the boundary of that rectangle is fully within the polygon. Should I just check whether there's any corners, polygon corners, that lie inside the rectangle? Is that necessarily always the case? If I check all corners... No, that doesn't prove anything. That would rule out this case, though. Hang on, let's think. Let's see what happens if I just check for corners as a last check. Like, if this is the edge case that's throwing me off, then maybe... Okay, so we get as far as saying, is line inside... Alright, so we've said this rectangle is inside, what we actually mean is... this rectangle is either fully inside or fully outside, but it doesn't cross over between the two. That's kind of what we're saying. Well, no, that's not. Oh, what? Get it? Just got back home. No, I'm still working on problem 9. I think there's some weird edge cases I'm not sure how to deal with. Like this situation here. I've always been assuming that if the boundary of a rectangle lies on the polygon, then the whole rectangle must lie on the polygon. That's not true. Because you could have this situation where like two parts of the polygon touch, just touch, then this dotted line is a rectangle. Each edge of that rectangle lies fully on the polygon, but there is outsideness inside that rectangle. So that's a weird case. So I need a clearer definition of whether something's lies on the polygon. Let's try tweaking this method then. If not all of that, return false. So if we find an outside point on the edge of the rectangle, then it's a false. But we don't yet know if it's a true. So let's just do one more check, and let's say if any corner oh, we need a method here now. I just loop through each pair of red tiles as in part 1. And did what? Yeah, I mean, I'm doing that. I'm looping through each pair of corners. Question is just how to work out if this rectangle lies inside the polygon. A loop for each rectangle checking for boundary segments. I mean, that's what I've done, and it works for the test case. But then, like, what happens when you have this situation? So, this rectangle here, from this corner to this corner. every edge of this rectangle lies like on boundaries or fully within the shape. But it has outside points in the interior of the rectangle. Is that your input? No, it's just an edge case I came up with. But I need to account for it, I guess. I mean, my assumption was that if all edges of the rectangle lie in the shape, then so does the interior. That was my assumption. This counterexample proves that that's not necessarily the case. Because my check was just, for each edge of the rectangle, check whether it's on the shape or not. And that worked for the test case. And if all four sides of the shape are in the rectangle, then so is the whole rectangle. That was my conclusion. But you can have outside points inside the rectangle. Without crossing its boundaries. Right, well, I'll try looking for corners inside the, rectangle. Corners. I mean, I would assume they don't give us shapes like that. I haven't really printed out the shape, but I'm guessing it's actually a nice shape. But if it was a nice shape, then I would expect this to actually work as is. I mean, unless I've just got some issue with this crossing point. This shouldn't matter, but we should put an else statement here. Let's see. So our leftmost edge is that. And we're saying outside is to the right. Wait, no. Yeah, this goes down. Okay. So the outside is to the right. Okay, that is, so that's our pointer to the outside. I'm saying if it does... Okay, and I'm saying if it doesn't cross any edges at all, I return true. Is that... I mean, I don't think that's even possible. It can't, because we know the line touches at least one corner, so that statement's never going to get hit. We should remove that because it's not even technically true. If it was just a floating line somewhere, it could float outside. Just see if that breaks it. So you think your part 1 may be the problem? Part 1? No, part 1's correct. What do you mean? My part 1 answer is correct, I think. Still, let me check. Four, 7, 4, 4. Yeah. Well, that's part 1. I'm not touching part 1 really. Ooh. Now I got 0. That's weird. What happened? So I think we just never found... Oh no, we do need that. What we're doing, we do need that. Okay, so I'm saying for each edge, if there is an intersection point, if they intersect, then that's already a sign that this line dips into the outside, but we check where the outside point is. So we look at that edge, we look at whether we have to look to the left or look to the right to find the outside. We take the point, and then finally we check if that point lies on our line, and it's not on the boundary of the shape, which we've computed as a set. Then we found an outside point which lies on the line. And if we get through without finding any such outside point, then we've returned true. So it's too low. That means we've missed a rectangle that's inside, which was actually bigger. That means somewhere there is a rectangle which lies in the inside the shape, but we've said it lies outside. That means there's a rectangle where one of its lines we decided was was not fully inside, but it actually was. That means one of these returned false when it shouldn't have. What if I just take this condition out? Is the boundary check somehow throwing this off? The boundary check was there to cover edge cases. It's a bigger number. No, is that smaller? Oh, hang on. Yeah, that's actually smaller. No, that's wrong then. If rectangle x1 what are these variables? So you're checking if the two lines intersect at all. And the intersection point is strictly along the line and not on the corner, because it will always intersect with the edge on the corner anyway, because it's a corner. So you're saying if it's strictly on the line. So if I just say just omit the corner, the edge at the points. Alright, well, I can try that. It's I can think of a million variations of edge cases that would break that, but fair enough. If they've given a way simpler input that I'm expecting, maybe. And I can also think of edge cases which would break what I've done, but still. So you don't even find a point that lies outside and prove that it lies outside by checking if it's on the boundary or anything like that. You just basically check if there's a crossing point on in the interior of the line. So like if I just take all that out. So I found an intersection point. And the point is on the line. Well, no, we know it's on the line. Oh, no. Okay, change this condition. So we found... So, intersection point of that edge is strictly not either of the endpoints of that line, is basically what I'm saying. If... Intersection is not equal to the first endpoint, and section is not equal to the other endpoint. Turn false. Let's try it. If it's just a really nice shape, then I don't know why what I did didn't work, but maybe there's an edge case which is actually fixed by this and not by what I've done. Is that not... Did I just get the exact same number? No. That's the same number, isn't it? It literally didn't change. Huh. Interesting. Let's check my crossing point. Because that's now the bulk of the logic. So if they're both vertical or they're both horizontal, we return no crossing point. So if it's vertical, we say the crossing point is the x value of line 1 the x value of the vertical one paired with the y value of the horizontal one. Otherwise, it's the other way around. Yeah. And then finally, we say if that point we found is on both lines, line segments, then we return P. So that relies on is point on line also being correct. Is point on line. Okay, so if it's a vertical line, then we want the x value to match and also the y value to be between the y values of the endpoints inclusive. Okay. And if it's horizontal, let's just flip all the x's and y's. Okay. We're not even using these clockwise, anti-clockwise things anymore. Let me try the 496. Is that right? Should there not be like 500? Copy and paste this in again. No, that's right. Yeah, I mean, we've got the right 97602 97602 50292. Okay, yeah. So if I go back to the test input, $50.24, that's correct. So not even using the boundary. Let's just comment out all the things we're not using then. Not using the boundary. Not using all this stuff, leftmost. We are using corners and edges. We're not using vector algebra. Get rid of that. So we want all lines to be inside for the possible rectangular edges, which are P1 to that, P1 to that, P2 to that, P2 to that. Yeah, that looks right. That's as simple as I can make it. So, I don't know, it must be edge cases then. I guess I'm gonna have to actually print out the stupid shape and see what it looks like. I don't know. If it's not a rounding error or something. Well, like, what I'm doing now is not using any... It's all strictly integers. Get crossing point. Is purely using the XY values of that. No, it's all integers only. I was doing some floating point algebra, but not anymore. Give you my input to confirm if it's an edge case. No. I don't need to do that. I was just trying to think if I could do a quick fix, otherwise I need to just debug properly, but I don't want to do that now. Probably next time. It might end up being after day 12. I'll just have to actually just draw what this shape looks like so I can find it. I think I caught a glance at somebody's post on Reddit or something, and it was like a huge, jagged, kind of like circle, but there's one big rectangle that juts into it. So it's basically a big Pac-Man. At least that's what theirs look like. It's probably similar. So I guess that the bit that juts into it cuts across a lot of big rectangles. So the ideal rectangle will be somewhere like in the top or somewhere in the bottom, going across this shape, but not crossing the thing. This really worked, because it seems like there's some very simple edge cases that could break this. Wait, so let me clean this up. Just, oh my gosh. Wait, so what happens if you've got like, you got the shape up here, and then you got the shape here, like this basically, and your rectangle is this corner to this corner. So does it say it's inside or outside? It says it's inside, doesn't it? According to what you did. Because nothing's crossing it. But that case seems so easy to come up, it's barely even an edge case. That's just like a very normal case. You're getting the same number before that. Well, yeah. So it might be that that case doesn't come up, but it's either that or the logic I was using just wasn't really that correct. I don't know. I was doing stuff with normal vectors and stuff. I don't know. But it seems really, really generous then if they don't even have an example like this, because I don't even consider that an edge case. That just looks like a normal occurrence to me, because you can draw a jagged shape and have lots of things like that. I suppose the rectangles just aren't even that big in that case. I don't know. Alright, I guess I just have to leave this till next time then. What is the best rectangle we found then? So that's the best one we found. It's probably something I can actually just figure out by eye when I've actually drawn the diagram, but is there a way I can quickly draw the diagram? Well, I'd have to just put in the, I'd have to get some library matplotlib or something. I cannot be bothered to do that now. I suppose day 12 is not going to be, well, we'll have to Let's see, how quickly can I just boot up matplotlib? So for each edge, let me Google how to use matplotlib. Plot shape edges in matplotlib. Oops. So for each edge, how to use this? We need the x coordinates as okay. Okay, so we've got the edges. So the x chords equals that. Y chords equals that. For edge in edges. Or we just do the no, it's just for corner in corners. I should call them vertices, not corners. X chords dot append corner dot x, y chords dot append corner dot y, and then try this. X chords. There we go. That's the shape. It's actually quite reasonably nice looking. All right. And we can plot the rectangle. Yeah, it's actually not, it doesn't look very tricky at all. Like, it doesn't have any, except that one big thing. All right, let's see what our rectangle looks like. So we want so P1, P2, P3 is gonna be pause. P1 dot p1 dot x, p2 dot y, p4 equals pos of p2 dot x, p1 dot y. So to plot a rectangle, so it's going to be like something like this code. Okay, can we go? Patches dot rectangle. So x, y. Was they want the bottom left corner? Okay, fine. This is okay, fine. Bottom left. Okay, just sort. So these equals p1, p2, p3, p4, vs dot sort. So the bottom left should be the first one. Equals vs0 dot x, vs0 dot y. Width will be vs minus 1 dot x minus vs 0 dot x. Height will be vs 1 dot y minus vs dot minus y. Line width, blue, face color, I don't know, pink. Okay, we need to plot the rectangle. So we've got a rect. Add. How does this work? Try this. So this is the initial plot, and then plot it again when we've got the rectangle pasted. Oh, for fuck's sake. Need to define less than. Wait, oh. I just closed it. It was empty. Is this plot or subplots? How do I... I'll plot them all on the same place. So plot, patches. Okay, where did I plot this? Take this, move it to the end. Move that there. We plot. Okay, don't show. And then do that. Is this gonna work? Why subplots? I don't understand this stuff. Why can't we just plot a rectangle? Why are we using... Why are we using axes? I don't care about axes. I just want to put a rectangle on the graph. Let's try this. Otherwise, don't fill it in. Just draw the rectangle. We don't need to... I wanted to fill it in, but that's not actually that important. So we do that. Alright, we'll just draw it using, draw the edge of the... Okay, get rid of this. Okay. So the new X chords is gonna be like... in for... Z in... P1, P2, P3, P3, P4, and Z. Z. We'll make this one blue. And just make it a bit thinner, I don't know. Okay. Alright. Go. Got to get rid of that. The grid probably doesn't even help. Take that out. We don't got no rectangle. What's going on here? Minus what? No, that's right. That's right. This is... To close the shape, the last point must be the same as the first point. I don't care about closing the... Okay, we can do that. I don't know why it worked before, but corner in corners plus corners 0. I don't know. do it like that. Is the second plot... No. What? Where's the rectangle? Or what are the values? Print the values. Let me see what's going on here. Is it off the chart or something? Wait, what's... Oh no, P1 is... I'm not using the right P1 and P2. That's some temporary variable from before. Well, it should be the right one. I don't know. Okay, do that. I think we've pulled some P1 and P2 from some place that we shouldn't have. From here, probably. Yeah, it's not from the best rect, it's just some arbitrary P1, P2. Still, there should be something plotted. P1, P2, P4, P3, P1. Yeah, do that. Well, that's that. I mean, that looks like a good rectangle, doesn't it? Maybe it's a bit wide and it should be a bit more squarish to be bigger. I don't know. Yeah, but there's no corners that would allow for that, so... And it's hugging the... God, why can't I get this rectangle right? P1... Oh yeah, obviously you don't go to P2. You go P1, P3, P2, P4. P2 is the opposite. P1, P3, P2, P4. This looks so spot on. Like, what am I getting wrong? Like, whoa. That's pretty much what you would expect. You would, because this corner allows you to take shape like that. Am I computing the area wrong? Is it the same area calculation as part 1, or is there a subtle difference? Let me check, because it's largest area of any rectangle, so it's including the edges itself. That was the same as before. And red tiles are always corners, aren't they? Yeah. So close. There must be just something subtle that's off, but that looks like it's the right rectangle. So the area, they're expecting a bigger area, and I've computed the area like P2x minus P1x plus 1 times P2y minus P1y plus 1. Yeah, that's right. It's the same. this rectangle, is it like identically on the edge there? Probably. Hello, Takakis. It must be something really subtle. Looks right, and area size is also in the right value magnitude. Yeah, that's what I'm thinking. It's just like, it's so right that it can't be way off. Like, even if we took it from the bottom side, that would be smaller, wouldn't it? Have you done this problem yourself, Takakis? Like, looking at, like, I came up with some crazy edge cases, which I think are valid edge cases that my algorithm doesn't account for, but I don't see anything in this diagram which looks like what I've theorized, so I don't think, like, this is a really regular looking shape. I don't think, for your area calculation, that is my area calculation. Which I copied from part 1. And it looks like they're asking for the same thing, essentially, in terms of, like, rectangle area, so... You see an issue with that? Well, that's a good sign. I would hope there is an issue with that. Let me have a look at what I did for part 1 again. So for part 1 I did... Let me just space these out. P2x minus P1x plus 1. P2y minus P1y plus 1. Am I still getting the right answer for part 1? 474, 849. Yeah. Do you need to plus 1 and take abs, or take abs first and then add 1? Oh. Oh. The answer is it should be like that. And I guess if it passed part 1, it's probably because the directions were happened to go in the right. Oh my god. Let me try this then. You're right, that it should be like this. Because the difference is that made positive, and then you add 1. Oh my god, was that it? That was wrong for part 1 as well, but that doesn't change part 1. Oh no, because I didn't change part 1 code, I changed part 2's code. Did I really? Hang on, so abs plus 1. What did I do for part 1? Yeah, I do get a different number. Interesting. But how the heck did that pass part 1 then? Because that was on the same big old shape. There's just a lot more rectangles that are valid. let's try this then. Is that bigger or smaller? Bigger. How did that pass part 1? What? Oh, all it needs is for the best rectangle to be okay with those with that parentheses, and it matters. So it just so happens this the particular rectangle in question that mattered. Oh god. I looked at that. Several times I worried whether that formula was right, so I looked at it and I looked at part 1 and I said, oh, if it matches part 1 it must be, but it can happen to be correct for particular rectangles, and it just so happened that it's a different rectangle from part 1. Oh god. Thank you. I would have been racking my brains for hours possibly, but because it also passed the test case. That's crazy. Alright, let's have a look at stats and stuff. Oh, 9. 9 has a very low completion rate, and also 11. But 11's kind of, we're still on that day. So 9 seems to be the hardest so far, in terms of completion rate. But I really dumbed down my algorithm to basically what Omaro did, and it worked. So it really was a very generous input. Like, there is so much I was accounting for that they could have done. Let me show the diagram that I made. Oh, I erased it. Well, okay, well that was one. Well, that's one edge case that doesn't come up clearly. But the thing I was really worried about before was damn it. Get rid of everything. Okay. The thing I was concerned about before was a really weird edge case, and that was what happens if you have this. So the edges are touching. They're just touching, kissing. Clearly this doesn't come up at all. I was trying to account for it. And the shape goes off like that. So this corner matched with this corner to make that rectangle. I think 10 was way harder than 9, but people are probably using external libraries for 10. Yeah, I mean, I did. I used Z3. You're right, actually, on a technical level, 10 is actually harder. It should be considered harder. So yeah, my counterexample here is you got this edge here, which is just touching this edge. So this outer rectangle boundary of it is technically fully within the shape, according to the definition of red, green, vertices, whatever. But it has an interior, disconnected interior, which is outside the shape, because this whatever. Can't quite draw it. I mean, okay, there we go. That's outside, and that's also outside because it's disconnected, but according to the rules, as I understand it, I think this is a valid input, which could have come up, but obviously it didn't. And I was really struggling to see a way to overcome that. Because it means I would have to... You could check the corners in the interior of the rectangle, but then even then, that's not necessary. You could, I bet I could come up with an even weirder case, which would... Anyway. Turns out it was actually a really, really nice shape. Alright, well, thanks to everyone, both Umara and Takakis, who gave me tips. Probably what I wrote before would have even worked without simplifying it, but yeah, it doesn't matter. So that means the only thing I've left unsolved is 8. And apparently 8's not that bad. Then maybe I'll do it today, but I don't really want to do it now. Let's see. Ten was borderline impossible to complete without Python. Yeah, it's... I mean, okay, so the Z3 does have a JavaScript version as well, for Z3 specifically. So JavaScript could use the same library and probably would manage fine. Other languages, I'm sure there probably are equivalents, but I don't know the names of them, and they're probably hard to find or whatever, I don't know. But yeah, since you're using GameMaker language, that's not something that would have any reason to include a theorem proving language or a logical problem solving language, because that's not needed. Yeah, most main languages have Z3 bindings. Yeah, Umara's been using GameMaker, so I guess that doesn't have it. Most standard languages probably do, yeah. Yeah, so it's not so much Python. In fact, there was an earlier problem where where Python really had the advantage. Which was it? Probably 7 or something. No, I don't think this. Hang on, there was one. I think. Oh, probably this one, because you've got unbounded ints being added up, and you've got parsing with white space and stuff to fiddle around with, and then you've got you could eval these if you wanted to. I didn't even do that, but you could eval, and that's also a shortcut in Python. Yeah, I think this problem really benefited Python. It's just saves you so much headache to use Python here. Alright, let's check the old leaderboard. So I've solved 2 problems today, so I've managed to catch up a bit. Captain Coda. Alright. Well, that's good. I can... I'll come back. I probably will come back today with problem 8. But that might be in like a couple of hours time or something like that. If not, then it will just be tomorrow after we solve day 12. If we solve day 12. Usually the final... Well, I mean, it's a different story now, isn't it? Because in past years, day 25 was Christmas Day. So generally the last problem wasn't too bad. And it was only a part 1, and it was usually not too bad. But now it's not Christmas Day, so he could absolutely make it an extremely punishing problem. Why not? Alright. Before I go, there's a couple of cleanup things I could do just to make sure my code is not technically incorrect. So that area formula definitely needs to be copied up to part 1 as well. Let's make sure it doesn't break part 1 as well. .849. Yep, okay. And then all this fancy stuff I did with... Man, I did so much cool stuff. It was mostly unnecessary, but we did stuff with normal vectors so that we know which side is outside at all times. Computing the boundary. And I've got all this intersection calculations using determinants and stuff, which was excessive. Get rid of that. And clockwise, anti-clockwise rotations of vectors. Don't need that. Unit vector stuff, don't need that. There we go, nice and clean. I'll run it one last time. Alright. See who's doing Advent of Code still. A couple of people. German, British. I don't feel like raiding right now because I don't want to hang around. I want to go. So, I'll just stop there. Thank you again for saving me hours of headache, potentially. I think I probably would have figured it out eventually. Not too long after, but yeah. And see you tomorrow for the big finale. Bye-bye.